Hey, feeling good, like I should. When in dark, I walk around the neighborhood, feeling blessed.
Alrighty, let's take a look at our homework for lesson 6.2.6. We're starting off with M&Ms. It has to do with solutions to an equation with one variable. So we've been working with one variable equations, and most of the time, you're going to get a solution, or you're going to get one solution, I should say. And we're just working through the process like you see in this example right here. 4x minus 1 is equal to 2x plus 9. Then we would work through that process by taking away 2 x's from each side and then adding 1 to each side, and you'd end up with 2 x's is equal to 10, and then divide each side by 2. So we see that our solution is x is equal to 5. So we're going to test to see that that solution is correct by plugging the number here for x and here for x and simplifying each side. 20 minus 1 is 19, and 10 plus 9 is 19, which verifies that this is the solution, and we would declare that as our solution. Now, sometimes you get more than one solution, but it's rare, but it is a situation like this, where if you had x squared was equal to 25, and you took the square root of each one of those, x would be equal to 5, but technically it could also be equal to negative 5, since the definition of a square root is whatever you multiply times itself to give you this as the answer. So not only do you have 5 times 5 is 25, but technically negative 5 times negative 5 also would give you 25 for an answer, because you'd be multiplying a negative times a negative. So there are some situations where you'd have a couple of solutions, but we're really not going to focus on this too much in middle school. That will be a bigger focus in high school. Most of the time you're going to find that there's one solution. But we will focus on a situation like this. Infinite solutions, meaning any number would work. This is an example of infinite solutions, where after you've simplified both expressions, it ends up they're the exact same expression. So whatever x is here would be here, and so you could put in a 0 there, and both of them would give you negative 2. You can plug in a 2 there, and both of them would give you 0. Any number you plug in for x is going to make this expression equal to that expression. So you can keep going on till infinity, until the end of time, and you'll never run out of possible solutions for this situation. So we're just going to say all numbers are solutions, or there are infinite solutions. And then the last situation is kind of like this one, where if you one expression is x plus 2 and the other one is x plus 3, anytime you plug in a number here for x, the side on the right is always going to be greater, one more than the side on the left. So there's no number that you could ever plug in there that would ever make that work. So this is a no solution type of a situation. So those are the main three. Most of the time you have one solution, but sometimes you've got an infinite solution, sometimes you've got a no solution. Let's see what we got here. Simplify and solve each equation below for x. Show your work and record your final answer. All right, so here's all the work shown. Here are our solutions. Now notice that B is no solution, because by the time you simplified everything, you ended up with 3x plus 18 had to be equal to 3x plus 24, and there's no way that's ever going to work. When you cancel out the 3 x's on each side, you're left with 24 is supposed to be equal to 18, but it's not. And so that's an indicator when this is a false statement. Let me just rewrite this. If this had said 24 was equal to 18, which is what it would have said, we would know that is not true. No, that's a no solution situation. Whereas here, for infinite solutions, by the time you sent in the dive bombers and started to simplify, everything simplified out completely. So this is the key right there. 2 x's is equal to 2 x's. That means whatever number you plug in for x, it's always going to be equal. So no matter what number you choose, it's going to be a solution. So you could say infinite solutions or all numbers are solutions. Either one of those are acceptable ways of giving that answer. Show the check for each one of these problems. Okay, so in this particular situation, they're trying to say that x would equal to 0. So if I plug in 0 here, that means 0 plus 2 is equal to 2. but I put in a 0 here, and that 0 minus 2 is negative 2. That they're supposed to be equal. If 0 is the solution, then this side should equal that side when I plug in the number 0, but it doesn't. So that means this is not the correct solution. Now, if I wanted to find the correct solution, I would take away an x from each side, give me 2 x's on the left, take away a 2 from each side, that would give me negative 4 on the right, and now we think negative 2 is going to be the answer. I bet you anything that is. Negative 6 plus 2 is negative 4, and negative 2 minus 2 is also equal to negative 4. Yes, this is the solution, not 0. And then looks like x is equal to 12 checks out for this because you end up with 3 times 10 is 30. And on the right side, you get 30 plus 12 is 42, minus 2 is 40, minus 12 is 28, plus 2 ends up giving you 30 for an answer. So yes, that works out as well. All right, what do we have here? Some steps in solving an equation are more efficient than others. Complete parts A through D to determine the most efficient first step to solve the equation 34 is equal to 5x minus 21. So if both sides divided by 5 to begin with, I mean, yeah, if you divide by 5, that's fine, but the problem is you end up getting fractions over here. We don't like that, right? And this is important to note, as long as you do the same thing to both sides of the equation, it's a legal move. So if I divide the left side by 5, I have to divide the right side by 5, which means I have to divide everything on the right side by 5, which is what they did. And this was the only thing that canceled out, but that left you with an improper fraction, and so did that. This is not efficient because we don't want to work with fractions. Subtracting 34 from each side, yeah, you can do that. That's not a problem. If you remember that Terrence and Stanley problem from a few days ago, or from last week maybe, we found out that this made it take one more step. So now you've got 0 is equal to 5x minus 55. So you're still going to have to add 55, and you're still going to have to divide by 5. So 3 steps, that's okay. It's not ideal, okay? Adding 21 to each side, that is by far the best, because now you only have one more step, and that's to divide by 5 to see that x is equal to 11 in this particular equation. All 3 suggested are legal moves, but which method will lead to the most efficient solution? I think this is the best one, followed by B, and A is the worst of them all. All right, Alex has a job delivering newspapers. He puts 20% of his earnings each week into his college savings account. Each week, he puts $16 into the account. So that means that 16 is 20% of however much money he's making every single week. So if you recall, the part over the total is equal, there's an A there, to the percent out of 100, then 16 is not his entire paycheck. That's a part. We would put the 16 on the top. And 20% always goes above the 100, right? That's where the percent goes. So that means that we're trying to find the total. And so we can do that. In fact, if you wanted to go ahead and simplify this fraction and call it 2/10 instead of 20/100, now you can see a giant 1. If you multiply times 8 here, why did that turn into a... Did I just do that? I don't like that one bit. Boom, boom, boom. So if you multiply this times 8, you'd multiply this guy times 8, and that's how you get your 80 for the total. Okay? So here's a diagram that you could show to represent that as well. Every 20% represents 16. So 40% would be 32. 60% would be 48. 80% would be 64, and 100% would be 16 times 5, which is 80. So that's another way of showing your total. Alex spends 10% of his earnings on snacks each week. How much does he spend? Well, spending 10% of a number, no problem. 10% of 80 is $8. And when Alex has worked for 1 year, he will get a raise that is equal to 15% of his current earnings. Okay, so his raise, if it was a 10% raise, it would bring him up to $88, right? So that would be $8 was his raise. But 15 is going to be 10 plus 5, and 5 is half of 10, so we're going to add another 4. to make it a $12 raise. So he'll now be making $92 per week instead of $80 per week. All right, factor each expression. Why is so much factoring going on here? We're not even using this anytime soon. All right, so looking for the greatest common factor, 16 and 4 have 4 in common. So we would take 16 over x minus 4. And so if you divide both of those by 4, 16 divided by 4 gives you the 4, and then that's 16x, so that's 4x. And then 4 divided by 4 is 1. And so we're going to put a minus sign there. And so this, wait. No, that's wrong. This is right. My bad. I'm going to change that. Hold on. That's more like it. So 4 times 4x is 16x, and 4 times 1 is 4, and there's a minus sign there. Okay. Here, the negative 10 and the 5, you could factor out. They have 5 in common, but I'd probably pull out the negative 5 as well, although you could have done just the 5, in which case this would have made that a negative 2 instead of a positive 2, and this would have been a positive x instead of a negative x. But they also have x's in common as well, so we'll divide out the x. And so remember, the whole idea here is you should be able to take and do distributive property here and get back to where you started. Here, 30 and 24 have 6 in common. The y and the x have nothing in common, so you're just going to divide each one of those by 6. 30 divided by 6 is 5. 24 divided by 6 is 4. Put the minus sign in, and now check it using distributive property, and you'll see that 6 times 5y minus 4x gives you 30y minus 24x. All right, last problem I'm thinking. Yes. All right, 3 different situations where we can take Cecil on the tightrope and use this as a model for solving algebraic equations. So both of these are tightropes. They're equal in length. So this expression has to be equal to that expression. So you get 2x's plus 7 has to be equal to the 13. Well, let's take away 7 from here, which means we have to take away 7 from the 13, which leaves you with 6. So take the 6 and divide it into 2 equal parts, and that means x would have to be equal to 3. 3 plus 7 plus 3 is 13. Yes, that works. So we know this is the correct solution. Here you've got 3j's plus 15 is 27. So let's take away the 15 from the top and the bottom. That's going to leave you with the 3j's have to equal 12. And so that means each j must be equal to 4. So 4 plus 4 is 12, plus 15 is 27. Yes, that's correct. And then here you end up with, what is it, 2n's plus 24 has to equal 44. So when you take away the 24 from the top and from the bottom, you end up with the rest of it being equal to 20. So 2n's has to equal 20. So each 10 must be, or each n must be equal to 10. So 10 plus 10 is 20, 26, 32, 38, 44, yes. 44 on the top, 44 on the bottom when n is equal to 10. All right, so that does it for this particular homework problem. Let's move on to the next activity. Take care, bye.
Hey, feeling good, like I should. When in dark,